So trivially, since we want to substitute p1 x1, so we don't have to divide both sides by p1 x1. So let's just leave it as x1 p1 equals to this result. That is x1 p1 is equals to a of x2 p2 all over 1 minus a. So we have to recall from equation 3. From equation 3, we have p1 x1 plus p2 x2 minus m is equals to 0, such that p1 x1 is this. So we have our p1 x1 as a open bracket s2 p2 over 1 minus a plus p2 x2 minus m is equals to 0. So whatever you have to do from here is to multiply all through by this 1 minus a. So when you multiply through by 1 minus a, you end up having just a of x2 p2. When you multiply this term we have here, when you multiply this term we have here by 1 minus a, this will cancel. I have this left. This one by 1 minus a, you have p2 of x2 times plus p2 of x2 p2 x2 times 1 minus a, then minus m of 1 minus a is equals to 0. So then from here, we should have a x2 p2 plus, when p2 x2 multiply 1, I will still have p2 x2. A times p2 x2 times a, that's a p2 x2, then minus m of 1 minus a equals to 0. So trivially, this will cancel this, right? So whatever I have left now should be p2 x2 minus m of 1 minus a. When you take this to the other side, you have m of 1 minus a. So divide both sides by p2, divide both sides by p2. This cancel this. So it is clearly seen that x2 is equals to m of 1 minus a over p2. So this result here gives the function for x2. I have x1 here and I have x2 here. So I have these two results. So these two results gives the Marshallan demand functions for the utility function. Okay. So the Marshallan demand functions is equal to, so we can start write it in this format. So this is a m of over p1 comma, and I have 1 minus a of m over p2. So that's the function itself. Then the next thing is to find the indirect utility function. How do you find indirect utility function? The indirect utility function itself, that is IU, and IU is actually equal to this utility function that you have here, which is a ln x1, but you have to substitute your x1. It's not going to be in terms of x1. So you have 1 minus a ln of x2. So this is a utility function given to us, but IU simply implies that you have to substitute back what your x1 and x2 is. My x1 is am1, am over p1, then plus 1 minus a ln of what? X2 is what? 1 minus a of m over p2. So therefore, the indirect utility function is equals to, so let's just write it very well. So this implies, can I write this in another format, that is, this a goes up here. So you can leave your final answer like this, or you go ahead and simplify. I have ln of am over p1 capital M raised to the power of a plus ln of 1 minus a m over p2. When this 1 minus a goes up, I have 1 minus a. Okay, so therefore, ln is common to both of them. The natural logarithm function is common to the two of them. So I end up multiplying this and this together. So when I multiply this and this together, whatever I have left now should be a m. I have am over p1 raised to the power of a. By the rule of logarithm, when you have addition, you go ahead and multiply, times 1 minus a of m over p2 raised to the power of 1 minus a. So the final answer I have here gives us the indirect utility function of this maximized utility. So this gives the final solutions to the problem that we have. So you recall this and this gives us the Marshallan demand functions, and the final result we have here gives us the indirect utility function. So guys, thanks for watching. Please remember to subscribe to my YouTube channel. Thank you.